Welcome to today's webcast, Coded UI Testing with Visual Studio 2013, Writing Your First Coded UI Test. My name is Colin Dembowski, and I'm an ALM MVP based in East London, South Africa, and I work for a company called Imaginet. I'll give more details on Imaginet's service offerings at the end of this webcast. My Twitter handle is @ColinDembowski, and I blog regularly to colinsalmcorner.com. Before we start today's webcast, I'd like to tell you a little bit about Imaginet. We have over 650 successful ALM customers and over 1,800 successful ALM engagements. We're a Microsoft Gold certified partner with the ALM competency, and in 2011 we were Microsoft's ALM Partner of the Year. We have only the highest level of expertise with Microsoft ALM technologies and a close working relationship with Microsoft. On staff, we have multiple Microsoft Regional Directors, TFS Rangers, Virtual Technical Specialists, and many Microsoft MVPs. In today's session, we're going to look at what is Coded UI. We're going to discuss some of the supported technologies. We're going to look at reverse engineering and action recording, recording additional actions and adding validations. We'll discuss finding controls, do some basic refactoring, and finally we'll run the automated test as part of a build, deploy, test workflow. We'll also look at Coded UI testing for Windows Store applications. So what is Coded UI? Coded UI is simply unit tests that interact with the user interface. I say unit tests because that's the framework that underlies the Coded UI test, so they behave and can run like the unit tests, but they do interact with the user interface. They're primarily used for functional testing. The Coded UI framework allows you to find controls, inspect control properties, and interact with controls. To enable this, it includes namespaces like mouse, keyboard, and gesture for Windows Store applications to allow you to click and interact with the controls on your applications. It's important to note that Coded UI tests are just code. So if you have some sort of validation that checks a database, well, you can add that code in and make that part of the validation for your Coded UI test. Let's look at the supported technologies. Coded UI testing supports any .NET 2 and up applications. It does require .NET 4 to operate, but your application can still target .NET 2. The operating systems supported are Windows 2008 R2, Windows 7, Windows 8, and Windows 8.1. Windows Store applications are supported, but only on Windows 8.1. Internet Explorer 8 and up are supported, and only in the desktop mode. The latest versions of Chrome and Firefox are supported. All Windows Forms applications 2 and up are fully supported. All WPF applications from .NET 3.5 and up are fully supported. SharePoint and Dynamics CRM Web Client are fully supported. There's some partial support for Win32 applications, MFC, and Dynamics AX 2012 client applications, as well as Citrix terminal services and Power Builder. Examples of applications that are not supported are SAP and Office Clients apps, Opera and Safari, Silverlight, Flash, and Java. For more details, you can click on the link or go to the link on the bottom of this slide. Also note that third-party controls, like Telerik controls, may or may not be supported depending on the vendor. There are two methods of creating Coded UI tests. In the first one, you create an action recording by running a manual test in Microsoft Test Manager. Then when you create a testing project, you can reverse engineer the existing action recording by simply selecting that option on the dialog that pops up. From there, you can use the action recorder to add additional actions or validations. The second technique lets you start manually with no code and start recording your actions manually or by hand immediately. We'll see both of these in today's session. Let's talk about running automated tests. The test can obviously be run from Visual Studio or from mstest.exe. I put those in brackets there because that's not truly automated, since you're having to kick off the test process. Automated tests can also be run from Microsoft Test Manager. This requires you to associate the code to the test case. Again, we'll see an example of this later on. The coded UI test can be run as part of a team build. This requires your build agent to run in the interactive mode so that it can interact with the desktop. Finally, you can run these tests as part of a build, deploy, test lab workflow. This also requires associating the code to the test case and also requires a lab environment to be set up with the coded UI function enabled. For our first coded UI test, we're going to run a manual test in Microsoft Test Manager and let it record the actions. We're then going to get Visual Studio to reverse engineer the actions into some coded UI. I'm going to click the Test tab, click on my test case, and hit Run to go and run the test. I'm going to select Create Action Recording and hit Start Test. Now we'll just run through the test. I'm going to mark each step as pass or fail as I go. This is important because every time I mark a step as passed or failed, it marks a method boundary when we reverse engineer the actions. Now we'll click Fahrenheit, validate that the table has updated. Finally, we'll close the browser. I'm going to end the test here. Now, to make sure that my action recording is working, I'm going to select the steps, press play to fast forward through the actions, and make sure that the test works as I expect it to. That's looking good. Let's go through to Visual Studio. Here I have Visual Studio open, and I've opened up the solution for the Fabricam Fiber website. Then select File, New Project, and under the Test heading in C#, I'm going to select Coded UI Test. We'll call this fabfiber.codedui. That'll create a new Coded UI Test project for us. Visual Studio then prompts us to select whether we're going to record actions or use an existing action recording. I'll select Use an existing action recording and hit OK. This will launch a query finder for me where I'll be able to find the test case that has the action recording. I'm going to search for all my test cases, and I'll select the test case that has the action recording I'm happy with. Visual Studio has generated 4 methods corresponding to the 4 test steps that we had in our test case. Let's open up the Test Explorer window and build our solution so that the test adapter can pick up the coded UI test. Let's right-click that and select Run, just to run the test as it is. That looks good. Let's do a little bit of cleanup. I'm going to rename this class to FabFiber Coded Tests. And we'll rename this method to Test Weather Converter. I'll just recompile to let the test window refresh. At the moment, this test just plays back our actions, and there's no validation yet. So what I'll do is I'll press Enter to open up a line between click Fahrenheit and close browser, and we'll add validation in. I'm going to right-click, and from the menu select Generate Code for Coded UI Test, and then use the Coded UI Test Builder. That'll minimize Visual Studio, and in the bottom right-hand side of my screen, open up the Coded UI Test Builder. Let's open up the web page and get it to the point where we want to do the validations. So I'll click weather and then click Fahrenheit. Now we can use this record button to record additional actions. I'll show you how to do that shortly. But for now, I'm going to grab the target icon and drag it. And as I drag it over my web page, you'll see a blue bounding box showing which elements on this user interface the testing framework has visibility into. We're interested in this cell here, so I'll let go. That'll pop up a dialog showing me all the properties that are visible to the framework. I'm going to click on the inner text property, which is set to 46 at the moment, and I'll click Add Assertion. We'll leave the comparator to R equal, though there are quite a few other comparators we could use. I'll leave the value as 46 as the default value, and we'll just add the message here, validation failed, if the assertion fails. Then I'm going to click the fourth button called Generate Code, and we'll call this Validate Conversion. And then we'll click Add and Generate. Let me show you how we can record additional actions. I'll click the Record button, and let's click on the Employees tab. So we'll generate that, and this is click Employees. And we'll hit Add and Generate. Let's close the coded UI test builder to go back to Visual Studio. You can see that Visual Studio has created two additional methods for us. The first one is our Validate Conversion method. Our second one is the Click Employees method. I'm going to delete the Click Employees method since we don't actually need that here. Let's run the test again, just to make sure that the validation is working. The test is passing, including our validation code, which means that it's able to validate that top left cell is equal to 46 at the time of our validation. However, this may not always be the case. If the Celsius value that we start off with changes, the Fahrenheit value of course will be different. In order to make sure our code is robust, we'll have to read the value of the cell first, do our own conversion, and then match it with the actual result from the page. To do that, I'm going to have to open up the UI map. I'm going to double click on the uimap.ui test file in the Solution Explorer. This will open up the designer for the UI map. The UI map is divided into two sections. The left hand side shows me all the actions that I have, and the right hand side shows me the control map. If we look at the actions and I click on the Validate Conversion action, we can see that there's a verify that the inner text property of 46 cell equals 46. If I click on that, it'll show me which controls in the control map it's using. We can see that it's going to UI 46 cell. Let's rename this. I'll right click and select rename, and let's rename this to top left cell. Visual Studio warns me that if we've referenced the original name, we're going to have to rename it, and that's fine. I'm going to right click top left cell and select the properties, and you'll see there's various properties here. I want to focus on the search properties. If I open that up, you'll see all the properties that Visual Studio is using to locate this particular cell on the web page. You'll see that there is a property here called inner text equals to 46. Let's remove that, since if the inner text is a different value, the coded UI framework is not going to be able to find that cell. We'll select OK. Let's rebuild our solution. So we can see that we have to traverse this tree going from UI map to UI weather forecast, this window, to forecast this document to content table, UI item table, top left cell. So that's how we would walk the tree to get to that cell. So let's change our code to do that. Before we click Fahrenheit, let's read in the value of the cell. I'll create an int called Celsius, and we're going to do an int.parse because the value of the cell is going to be a string, and then we'll walk down the UI map. So we'll go UI map, .UI weather forecast window, .UI weather forecast document, .UI content custom, .UI item table, .top left cell, and the property we want to read is the inner text property for that cell. So we now have the value of the Celsius reading before we've clicked Fahrenheit. Let's quickly do our own calculation. We'll do the conversion to Fahrenheit. Now we want to override the value, the default value used in the validate conversion method. We can do this by overriding the validate conversion expected values property. So for every validation method, the UI framework generates a corresponding expected values property that allows us to override the expected values. We want the top left cell inner text to equal to expected.toString. Let's run that test. It says the test has failed. Let's go and look at the failure. It's telling us that it expected 36, but the actual was 46. If we look closely, we'll see that we've made a mistake in our expected values. Let's run that again. Now the test is passing, and it's robust to be able to work no matter what the starting value is. Let's now refactor the code a little bit to make it a little bit cleaner and more extensible for future test cases. If we expand the uimap.ui test, we'll see that there are two files, the uimap.cs and the uimap.designer.cs. We don't ever want to change code in the designer.cs file because that'll be regenerated every time that we edit the uimap or record additional actions or validations. However, this is partial classed into the class that sits inside uimap. We can make any customizations that we want inside of this class file. Let's create a public void method called validate that takes in an expected result. Since we're in the uimap class, we can just access the methods and properties from the uimap. So let's override the top left inner cell text of our validate conversion expected values. And then we'll call the validate conversion method. Let's go and clean up our test quickly. So here we can say validate conversion expected, and use the overrided method that we just created. Let's run our test again. We can further extend this test by changing the browser that opens up when we play back this recording. By default, the coded UI test will launch the IE browser. We can record actions in IE, but we can play back into Chrome or Firefox. I have Chrome installed on this virtual machine. So let's see if we can get the coded UI test to play back in Chrome. In order to do that, we're going to have to customize the Open Fabricam Fiber site method. Again, we don't want to mess with the existing method inside the designer file, so we'll create an override in our uimap.cs file. And we'll pass in a boolean called use Chrome. Now we'll have an if statement that says if we want to use Chrome, we just set the property browser window.current browser is equal to Chrome. Then we'll call the Open Fabricam Fiber site. There are a couple of prerequisites you'll need before you can do this. You'll need to install the Selenium components. You can find out more information on the MSDN site. Let's change the name of this to Test Weather Converter in IE. And we'll copy and paste this test method to create one to test the same method in Chrome. We'll do a build so that the test adapters can pick up both of our tests. And let's run the Chrome test. The coded UI test is now running the test inside the Chrome browser. I've now added this coded UI project to my Fabricam Fiber call center website solution. Let's check this into source control. And I'll enter the comment added coded UI tests and hit check in. I have a continuous integration build on that code, and so Team Foundation Server is going to queue a new build that's going to build my website as well as the coded UI test project. In order to run this coded UI test as part of a lab deploy workflow, I'm going to need to associate this code to the test case that we're automating. I'm going to search my work items for work items that have the word weather in it. There's test case 251. This is the test case that we got the action recording from. I'm going to double click it to open it up. I'll select Associated Automation and select this button with the ellipsis on it to choose the method that automates this test case. This doesn't have to be a coded UI test method. In fact, it can be any unit test. However, in this case, we do have a coded UI test called Test Weather Converter in IE, and I'll select that. We'll save the test case. That changes the automation status of this test case from not automated to automated. Let's go check on our build. Fab Fiber Code 1005 build has completed. And I'll open up the drop folder. And in the drop folder you can see this DLL, Fab Fiber Coded UI.dll. It's important that this Coded UI DLL is in the same location as the other binaries for my application for the build, deploy, test workflow to work. I'm going to open up my build, deploy, test workflow, which is this Fab Fiber Lab workflow. I'll right click and select Edit Build Definition, and I'll come to the Process tab, and I'll open up the wizard by selecting the ellipsis to edit the details of the lab workflow. In environment, you can see I'm targeting an environment called Web Lab. This is a standard lab environment that I've set up that contains a database server and an IIS server. In build, you can see I'm selecting the Fab Fiber Code build and selecting the latest one as the source of the binaries I'm deploying. On the Deploy tab, I'm using various scripts to deploy my database out to my database server and to deploy my IIS site to the web server using Web Deploy. This is how the website got to the web server machine in the first place for us to test. Now we're going to open up the Test tab and select Run these tests. We have to select the plan that contains the tests. I only have a plan called Default, and if I open this up, there's only one suite also called Default, and the test case lives in that default suite under the default plan. I'm going to use the Windows 8 configuration. The configuration is just the default, and I have some automated settings called Web Lab Automated, which define which diagnostics are going to run on the lab machines during the course of my test. I'll hit Finish. I'll save that build definition. Let's right click and queue that build. I'm going to double click the Fab Fiber Lab running build so we can monitor the workflow. Right now it's doing the deployment. Let's open up the web server so that we can see the tests running there. This green box here is the test agent running in the interactive mode. The test agent needs to run in the interactive mode in order to run coded UI tests and interact with the desktop. You can see that the test agent has just deployed the build. In this case, that means deploying the website to its IIS. The agent is now running the tests, and we can see that it's launching the test weather converter in IE test case. And here we can see it running through the coded UI test. Here we can see the build report. We can see that the build succeeded, and we can see the test run details to see which binaries were used for our test. And we can click on this View Test Results link to open up the test results in Microsoft Test Manager. Here we'll be able to see which tests were run, what their results were, and any attachments. Visual Studio 2013 supports coded UI test for Windows Store XAML applications. You'll need to be running on Windows 8.1 for this to work. Here I've opened up Bing Calc. It's a sample application that I created, just a simple calculator application, just to demonstrate the capabilities. I'm going to run this on the local machine just so you can see what the calculator looks like. Here I'm able to add, subtract, multiply, and divide. Basic calculator functionality. And there's a nice desktop background from Bing. Let's close the application by gripping it at the top and dragging all the way down. Let's also make sure that the Bing calculator is pinned to our start page. I'll type Bing and then right click the Bing Calc and select Pin to Start. If I move over a little bit, you can see the tile on the start page for the Bing calculator. Let's go back to our desktop. I'll hit stop to stop debugging. And now we'll add a coded UI test. I'll right click the solution and select Add New Project. And we'll go to the Visual C# Windows Store settings, and here you can see the coded UI test project is under this group of project templates. We'll call this Bing Calc.codedUI. You'll see that the dialog that comes up is slightly different to the dialog that we got when we weren't running on Windows 8.1 projects. This is because action recording is not supported for Windows Store apps. So we'll select Manually Edit the Test and select OK. Let's do a little bit of cleanup on the names. So I'll rename this to Bing Calc Tests. And we'll rename this method to Test Calc Can Add. The first thing we'll need to do is to launch our calculator application. There are two methods that we can use for launching the application. The first one is by using the xaml-window.launch command. I'll create a variable called calc, and we'll use xaml-window.launch, and the launch takes in a string, and the string is called app package family name. Let's give it an empty string for now. We can then run our tests and later on call calc.close in order to close the application. In order to find the ID to launch, we can right click, select Generate Code for Coded UI Test, and use the Coded UI Test Builder. That'll launch the test builder and take us back to the start page. I'm going to again use my target control and move up to the Bing Calc tile. When I let go, I'll see some properties. The second property listed here is the automation ID. I'm going to right click the automation ID and copy the value to the clipboard. We can then close the coded UI test recorder. We're not actually going to record anything. And I'll go into that empty string from earlier and paste. And that's how we can launch using the xaml-window.launch. If I look at the test window, I can see that there's a lot of tests here. In order to separate out our coded UI tests from our unit tests, I'm going to use some traits. Just below the test method attribute, I'm going to create a test category attribute, and let's call this coded UI. Then I'm going to come to the grouping drop down here and select traits. We'll then recompile, and now you can see that our coded UI test is grouped. Let's right click the test calc and add and run this just to see that we can launch the application successfully. It was very quick, but it did launch the application as well as close it. Now I'll show you the other method. Let's remove these lines of code. We'll right click, select Generate Code for UI Test and use the Coded UI Test Builder. Again, I'll take my target and drop it over the Bing Calc tile, and I'm going to expand this flyout here, and here you can see the hierarchy of controls. Selecting the UI Bing Calc List item, I'm going to select the Add Controls to UI Control Map button in the top left, and that'll add it to the control map. I can then click the Generate Code button and just hit Generate with no method name. Since we're not generating a method, we're just generating the control hierarchy. Let's close the builder. In the solution, you can now see that the UIMap.UI test has been added in to the Coded UI project. For Windows 8, we can use the gesture namespace in order to simulate gestures. If I scroll a little bit to the top, you can see there's a namespace shortened to keyboard in Microsoft.visualstudio.testtools.uitesting.keyboard. There's also a similar namespace for mouse. You'd use keyboard and mouse to interact with WPF applications and Windows Forms applications and even Windows Store applications. However, in order to simulate gestures on a touch device, we'll have to use the gesture namespace. So we'll type gesture dot, and you can see there's many gestures that we can choose from. I'm going to use the gesture.tap. The gesture tap method will take in a screen coordinate or a control. Let's give it the control that we've added. So we'll walk down the tree again. UI map dot start menu pane dot start app list dot Bing calc group dot Bing calc list item. Of course, we could rename that control just to make it a little bit easier to discover if we wanted to. Closing the application in this method is a little bit harder since we don't have a reference to the window. We can, however, use a swipe gesture. I'll show you how to generate the close method a little bit later on. Let's generate the close method now. We'll let Visual Studio create a method stub for us. And this time we're going to use the swipe gesture to grab the application on the top pixel row and drag it all the way down the height of the screen. That'll close the application. Let's create a variable called middle, which we'll assign to the width of the calculator control. However, at this point we don't have the calculator control in our control map. So let's go and create that. We can right click anywhere and select Generate Code for Coded UI Test and use the Coded UI Test Builder. Again, we'll click on the calculator just to make sure we're there. Then I'll take my target icon and again I'll drag it. And I'll just drag it onto the background of the application. That'll be the whole Bing calculator window. I'll expand the flyout and again use the Add Controls to Control Map button to add that in. Let's generate that code and close the test builder. Now again we'll walk down and there's the UI Bing Calc window, and it has a property called width which we'll divide by 2 to get the middle. Then we're going to use gesture.slide and we're going to slide on the Bing Calc window. Our starting point is going to be a new point which has its x coordinate in the middle and 1 for its y coordinate, and we're going to swipe straight down, so we're going to use the same x coordinate for our end point, which is going to be middle, and this time we'll use the height of the window minus 1. So that'll slide down from the top right to the bottom of the window. Let's run just to make sure we can open and close our calculator successfully. Let's now generate the coded UI map for some buttons on our calculator. Again, I'll right click, generate code for coded UI test, select the coded UI test builder. Let's open up the Bing calculator, and now let's drag onto the number 4 button. I'll use the flyout here. I'm going to right click and rename this to button 4, and then add that to the map. Let's repeat the same thing for a few more buttons. And finally we'll do it for the text box with the result. Now we'll click the Generate Code button to generate the code for the 5 buttons. Let's close the builder to go back into Visual Studio. Now that we have those controls, we can start constructing our test. Let's again use the gesture.tap. So we'll first tap UI map, Bing Calc window, button 4. Then we'll tap button plus. Then we'll tap button 5. Then we'll tap button equals. And finally we'll do a validation. Let's record our validation. I'll right click, select Generate Code for Coded UI Test, and use the Coded UI Test builder. Now again we'll target our text box, and this time we'll look for the text property, and then we'll hit Add Assertion. Let's use a default value of 9 since that's what our first test is going to end up on. And let's put calculator calculated incorrectly as the error message for this if this assertion fails. We'll call this validate result. And we'll click add and generate. Let's again close the test builder, and now we have the validate result method. Let's now right click and run that test. The test passed, and it's looking good so far. I'm going to right click button 4 and select Go to Definition. Here we can see the button 4 method and the button 5 method that get generated from the UI map. We can see that they're almost equivalent except for the search property, which searches for a particular property name. Let's refactor our test in order to make this more manageable and improve the look of the code. Again, we'll expand the UI test file and go into the UI map partial class where we can add our customizations. Here we'll make a public void method called tap button, and we'll take in a string called button to press. We'll create a variable called button, and we'll instantiate a new XAML button. We'll just resolve the namespace. A new XAML button, and the parent of the XAML button is going to be the UI Bing Calc window. let's go back to the designer file and copy out this search properties portion of code. Then we'll set those search properties on our button, and instead of hard coding it to a value, we'll select the button to press variable that we're passing in. We'll then call gesture.tap on that button. Let's also make an override for our validate method. We'll create a public void validate result method that takes in the expected result, and then we'll override the validate result expected values result box text with the value that we pass in. Finally, we'll call the validate result method. Let's compile, and let's go and change our test. We'll use our tap button to tap 4. Then we'll tap the plus button, then the 5 button, the equals button, and finally we'll validate the result is equal to 9. Let's again run that test just to make sure that everything's working. We can see that the test failed. Let's go and look at the result. Here we can see that the expected was 9, the actual was 99. If I switch back to the calculator, you'll see that it's actually open. What we may want to do is add a button press to the C button just to clear whatever's there. Let's add that into our test to make our test a little bit more robust. Let's run that test again. That looks better. Let's now copy and paste this test to create a subtract test case. And let's use some different numbers. Let's try 9 minus 3 is equal to 6. We'll build so that the new test appears in our test window, and let's run that test. So our subtract test works. We can of course add many more tests using the components that we've created using the Coded UI framework. We're ready to run this automation test as part of a lab. Again, I'm going to right click the solution and select check in to check these changes in. I'll enter added Coded UI tests as the comment and hit check in. That'll trigger a build that'll build this application along with the Coded UI test DLL. Let's go and look at our builds. While that build's running, let's associate our test methods with the test cases that we're going to automate. I'll type in Bing Calc to search for work items. Let's open up the test Bing Calc and add test case. Click on associated automation and associate the test calc and add method with that test case. Let's do the same for the subtract test case. Our build is completed successfully, which means we're ready to test. Let's open up the Bing Calc Lab and edit the build definition. I'll select Process, and we'll open up the wizard. And let's again go to the Test tab, where we'll select Run these tests in the environment. We'll select the plan called Win 8 Tests, and you'll see here I've got a suite called Automated Tests. That's where those tests live inside of that suite. And I'll use the default settings, which define the diagnostics that are going to be collected while we're running the test. Let's save that, and let's queue that build. I'm going to minimize Visual Studio and bring up the test agent. Let's go back to Visual Studio so we can see the completed build. Here we can see that the build has completed successfully. We can see that it's run 2 tests, and we can see where it got the binaries from. And we can click View Test Results to open up the test results in Microsoft Test Manager. Thank you so much for attending today's webcast. I'll now hand over to Becky, who will tell you some more about our upcoming events and special offers.
Thank you, Colin. If you'd like to know more, if you enjoyed the webinar today and are interested in adopting automated testing for your organization, Imaginet offers our Visual Studio Automated Testing 10-day Quick Start. In this Quick Start, Imaginet will teach you best practices for test selection, extension, data binding, maintenance, frameworks, community extensions, and other real-world scenarios revolving around automated coded UI testing. This Quick Start includes automated test development and execution using one of your applications. It also includes support and training for your team, as well as a high-level ALM assessment so you can understand how automated testing is going to fit into your overall application lifecycle management vision. If you're interested, just email us at info@imaginet.com. Imaginet offers a variety of free webcasts and events. To get information on or to register for any of these free webcasts or events that we have coming up soon, please visit our website at www.imaginet.com/events. We're now covering a variety of topics including Visual Studio 2013, Team Foundation Server, Application Lifecycle Management, SharePoint, and also Microsoft.NET. In addition, Imaginet has a variety of upcoming training classes. We have an accredited core Kanban using Team Foundation Server 3-day class. These classes are held monthly in Dallas, Texas, and can also be brought on site privately for your company. We also have a testers training class with Microsoft Visual Studio ALM tools. This is a 4-day class and is also held publicly in Dallas, Texas. And again, this class can be brought on site privately for your organization as well. For more information or to register for any of our upcoming classes, visit www.imaginet.com/training. Imaginet offers a huge variety of ALM planning and implementation services. We offer assessment and envisioning workshops, migration planning workshops, and deployment planning workshops. We can also assist you with any of your Team Foundation Server upgrades to the latest version, such as 2013. We also offer remote support and other quick start engagements for lab management, test manager, automated testing, load testing, quality assurance centers of excellence, and test centers of excellence. We also offer integration support for Team Foundation Server to other tools such as Microsoft Project and Quality Center. And finally, you can visit Imaginet's Visual Studio website And this is truly your one-stop hub for any and all of your Visual Studio needs. Just visit visualstudio.imaginet.com. If you have any questions or need any more information at all, please feel free to contact us at info@imaginet.com or simply by calling 972-607-4830. Thanks again, and we hope to see you on another Imaginet webcast.